Let's talk about how we can address some of the vulnerabilities and security issues around wireless access points, or as we commonly call them, Wi-Fi or Wi-Fi networks. So we've seen how it's possible for someone to stumble across and just find a network that is available and open to the public or is easily compromised. So one of the things that is suggested as a remediation strategy is to just not advertise SSIDs, and that means don't advertise the network as being available. A Wi-Fi network is not necessarily not connectable to if the SSID is not advertised. It just means that you have to know the name of the network before you can connect. So it makes it harder to do the war driving that we've talked about. So this is a not exactly the strongest remediation approach, but it's part of your security solution. This is sort of not the thing that will keep you safe on its own, but it's just good practice if you are not trying to get people connected to this network that you weren't already expecting to be connected to this network. So for example, if you have a particular wireless network at your office or place of business that is for specific devices to communicate with your infrastructure, you don't need to advertise those SSIDs for just the public at large. So to go with that, we can talk about having isolated networks or segregated networks. So what this means is, even if we have Wi-Fi that's available for public use, suppose in a doctor's office while people are waiting, the doctor would like people to be able to connect to wireless so they can do browsing or watch videos or whatever else. So it's a good idea to not have that be on the same network as, suppose, the doctor's electronic health record system. So that's the situation where we would have at least two Wi-Fis, and one of those would be the wireless network for the guests, and one would be the one for internal use. And you might have actually seen this if you go to a lot of public places and try to log on. You'll see there's sometimes something, foo_bar _ guest, foo_bar _ private. And that's where our previous suggestion also comes into play, is that actually only the guest one should really even be visible. The other one should be not even advertised, so as not to tempt any cyber attackers into trying to connect to it. And the other thing is, maybe don't even have a guessable naming scheme for your wireless networks. There's no real reason for the names to be for a particular standard. So suppose if you have foo_bar _ guest, you don't need to have another network that's even similar in name, because that would help the attacker to try to connect to it by guessing. And another thing is that with the private networks or with really any wireless network that you have, if you're using standard wireless router technology, it's a good idea to just not have that be on some kind of default factory configuration. And what I mean by that is, if you bought a off-the-shelf router, very often the router will have a common, well-known set of admin credentials. So it will have something like password for the password, or it'll have like admin for its username and password. And if somebody doesn't change that, then it's very easy for an attacker to get in. And of course, once an attacker gets into the admin configuration of a wireless router, they can start adding all kinds of malicious things, like they can inject some traffic sniffing in there. They can reroute things so that legitimate requests go to illegitimate sources and collect information that way. A lot of different attacks can happen once a attacker has access to admin capability on a compromised wireless network. And so the important thing here is that practice of security hardening. And security hardening is something we talk about in terms of software development as well, where we say, oh, harden that application or harden that server. But all it means is that we look at the security configurations, we look at the configurations of whatever application or appliance or utility we're working with, and we say, do those look secure enough according to our standards and according to what we know about the threat profile? And if not, then we perform some activities of remediating that. And sometimes that's iterative, sometimes we do it all at once. But the idea is that for something like a default router configuration, we before we even really bring it online, we go through, and the first step is go and change the default credentials, or we just have standard special images where we change the firmware on the router so that it comes with a hardened version of the firmware that runs the router, so it doesn't have any of the default security holes in it or security kind of easy to access configurations. And so it wouldn't have admin as the username and password. And another thing which is a little harder to enforce, but is actually pretty solid in terms of wireless security, is doing address filtering, especially like MAC address filtering, where we know which machines we're expecting to connect to our network. And then because we know that, we can actually restrict that only those machines can connect to a particular wireless network. So that way, unless someone knows how to spoof, fake a MAC address, which should be unique to every machine in the world. If you've never seen a MAC address, it's this semicolon separated kind of hash-looking, very long string of alphanumeric characters, and that's the MAC address of every single machine that can be used to uniquely identify it. And if someone knows how to spoof it, this of course could not work unless it's being used in conjunction with some of these other security measures. But it's definitely one of those security measures that people serious about security on a particular network will use, which is tell me about your computer, I'll register it with the network, and then when you try to log in with your credentials, it'll allow you on. But if even you try to use a different laptop or desktop or phone, and you have valid credentials, it's not going to work because you're doing it from a different machine with a different MAC address. And important to understand that Mac here does not mean Macintosh or Apple, it just means machine. And of course, the one that is the most popular and the one that everybody might know about is a WPA2. And that is a standard which is used for security on the wireless connection, and it's the one that people think of when they think of Wi-Fi passwords. There's of course WPA1 as well, is just an older version of the standard, and WPA stands for Wi-Fi protected access, or it can be Wi-Fi protected access 2, I guess, if you're talking about WPA2. And these security protocols, they're international standards. So when browsers and really any part of your technology is implementing wireless connectivity, any of your laptops or devices, then they will have a capacity for connecting to a wireless network that's protected by WPA. And WPA will also be available on all modern routers or wireless broadcast devices. If they don't, then be careful, watch out. It's probably not one that you want to use. And WPA is just, as we said, it's a secure protocol for checking credentials, and essentially it lets you figure out whether somebody is authorized or not authorized to join the network, because they'll have a Wi-Fi password, as we think of it. And a lot of times these Wi-Fi passwords you'll see are those kind of very long characters of random kind of hacks or numeric nature, but they can be just passphrases as well. And that depends on the administrator of the network, how they've configured it. So these are some of the ideas around how in the modern security game people will secure against wireless vulnerabilities.